Okay, this is the last video for Chapter 6. And I'm just going to give you a heads up that I'm going out of order from your note sheets. So just try to find where I'm at and follow along. We talked about binomial settings and binomial distributions in the last video. In binomial setting, the number of trials is fixed in advance. But what if instead we wanted to roll doubles? We wanted to keep rolling until we hit doubles. Or in basketball, we might attempt a three-point shot until you make one. This is a whole other setting. This is what's called a geometric setting, which is what we're talking about in this lesson. So, what are the conditions for a geometric setting? First of all, just like with the binomial distribution, it has to be binary. And again, the possible outcomes of each trial can be classified as either success or failure. It has to be independent. Trials must be independent. And then the goal is to count the number of trials until the first success. That's different from the binomial. And the success on each trial, the probability of success must be the same. So instead of bins, geometric is going to be bits. So always check your bits. What is a geometric random variable? What are the possible values of a geometric variable? Well, in a geometric setting, we define the geometric random variable y to be the number of trials needed to get the first success. The possible values, of course, in a geometric random variable would be 1, 2, 3, on into infinity, depending on how long it takes you to get the success. What are the parameters of a geometric random variable? Well, the parameters are p, the probability of success, and k, any one of those possible values for y. Okay? In general, how can you calculate the geometric probabilities? Is the formula on the formula sheet. Okay, geometric probability is the probability that y is equal to k, the number of times it takes to get the first success, is equal to 1 minus p to the k minus 1 power times p. In the calculator, we do geometric PDF pk if y is equal to k. And in geometric CDF, it's going to be we use that for when y is less than k. And of course, we'd use it for y is greater than k by subtracting it from 1 as well. And is this formula on the sheet? No, the formula is not on it, but however, you can geometric probabilities can be found using the complement rule right here and the multiplication rule right here. All right, so on average, how many rolls should it take to escape from jail in Monopoly? That's if you don't have a get out of jail free card. So on an average, it takes 6 rolls because our probability is 1/6. In general, how do you calculate the mean of a geometric distribution? And is this formula on the formula sheet? Okay. Y equals y is a geometric random variable with probability of p on each trial. Then its mean or expected value is 1 over p. So on our jail, get out of jail, remember that the probability of rolling doubles is 1/6. That's 6 rolls with out of 36 trials. There's 6 possible ways of getting doubles out of 36 trials, 36 possible trials. All right, so 1/6, to do that would be 1 over 1/6, which of course we already knew was 6. And is this formula on the formula sheet? It's not on the formula sheet. So I didn't write that in there, but it is not on the formula sheet. Okay. What is the probability that it takes longer than average to escape from jail? Now remember, that's going to be is greater than 6, because 6 is the mean. What is the probability that? What does this probability tell you about the shape and distribution? Okay, since we want greater than, we're going to use the complement rule, 1 minus the probability of y is less than or equal to 6, which is 1 minus probability of 6, probability of y equals 5, 4, and minus the probability that y equals 4, minus the probability that y equals 3, etc., all the way down to probability that y equals 1. So this is that probability. 5, 6, and 1/6. There's our failures and our successes all the way down, and subtract them from 1, and we get 0.3349. So how could we do that on the calculator? Again, we're doing a less than, and so we would do 1 minus, since we're trying to find greater than, 1 minus the geometric CDF of 1/6, 6, and you're going to get the same answer. It shows that 33% of the data is above the mean. So that means that our mean has been pulled towards the right, so it's skewed to the right. Okay, another Monopoly game. All right. In the board game Monopoly, one way to get out of jail is to roll doubles. Suppose that a player has to stay in jail until he rolls doubles. The probability of rolling doubles is 1/6. Explain why this is a geometric setting. Okay, again, what are we checking? We're checking bits. So, here we go. Binary, yes. Doubles is our success. Failure would be don't roll doubles. Independent, yes. Trials, yeah, we're going to keep counting until we come up with our first success, and then we'll get out of jail. And success, yes, the probability stays the same. It's always going to be 1/6. Define the geometric random variable and state its distribution. Okay, the geometric random variable in this is the number of attempts it takes to roll doubles one time in the geometric distribution. Find the probability it takes exactly 3 rolls. So, probability that it takes exactly 3 rolls, P y equals 3, is 5/6 to the second times 1/6, which is 0.116. And since the probability, find the probability that it takes to roll more than 3 rolls to get out of jail. Since there is an infinite number of possibilities of y greater than 3, we'll use the complement rule. So we're going to use 1 minus the probability that y is less than or equal to 3. And again, we'd find it this way. Or, of course, once you wrote this all out, you can stick it into your calculator. 1 minus geometric CDF in this case, since it's less than. All right, and so what does that mean? Again, I know some of you don't like telling us what it means, but if a player tried to get out of jail many, many times by trying to roll doubles, about 58% of the time, it would take more than 3 attempts. Okay? So what's the difference between geometric random variable? The big difference there, and binomial random variable, the big difference is in a binomial, you have a set number of trials that you're doing. On the geometric, you just keep doing the trials until you get a success. That's the difference in them. All right? Okay. Check your understanding. So stop. Check your understanding on 401. And check your understanding. Check bits. And, of course, it is binary. Successes are roll doubles. Failures are don't roll doubles. Yes, it's independent. Rolling dice is always independent. Trials, yes, we're going to keep counting the trials up until and including the first success. And then our success, yes, the probability of success is 1/6 for each trial. It does not change. So that makes it geometric. Okay? Next one, we're going to find the probability of T, which is 0.1157. So there's about a 12% chance that you will get the first set of doubles on the third roll. And in the game of Monopoly, a player can get out of jail free by rolling doubles within 3 turns. Find the probability that this happens. So that's in 3 or less. And we get 0.4213. Okay? Good luck on your homework. Have a wonderful Christmas.